Hello viewers, welcome to the part 3 of the step-by-step Oracle DataGuard series, and in this part we are going to learn about the administration and monitoring of your DataGuard system using OEM. So viewers, in this series I am covering various topics on DataGuard, starting with architecture, implementation, administration, management and monitoring, etc., which I am listing below. Each of the topic may need one or more tutorials to cover it completely. I assume you are already an Oracle DBA or familiar with at least the basics of Oracle database architecture. I will keep everything simple so there won't be any difficulty in understanding the concepts even if you are a beginner. So far in this series, we created a physical standby database using OEM. We discussed about the architecture, configuration, DataGuard broker, and a few useful DataGuard administrative commands in SQL and DataGuard broker like switchover, failover, reinstate, etc. If you have not watched the previous parts in this series, I suggest you watch them first to get a better understanding on what we will discuss in the next. Please note that whatever commands I am using in this tutorial, they are all available in a shared document in my Google Drive. You can access that using the link in the description of this video below. Moreover, I am using Oracle Enterprise Manager extensively in this whole series. If you want to learn more about OEM and become a master in OEM, starting from installation, monitoring, alerting, upgrade, patching, etc., please watch my 16-part YouTube series named Mastering OEM, for which I have given the link in the description of this video below. Here is a recap before we proceed. So I have my two Linux servers named Linux 1, which is my primary server, and Linux 2, which is our standby server. And the primary server has the primary database with the name testdg, for which I have already set up the environment, and we will simply call the DataGuard manager command prompt. From here, I logged in as sys, and I'll use the command show configuration. And we see that the testdg1 is currently the primary database and testdg2 is the physical standby database. And our DataGuard broker configuration is working fine. Now let's go back to our OEM console. I will log in to my OEM system using sysman user. And then I will list out all our target databases. And as you can see, this testdg1, that is the primary database, and testdg2, that is the standby database, both are listed as target databases in my OEM system. Now I will click on the primary database to go to its home page. And once we are in the home page of the primary database, we'll go to this availability menu item, and under this, these four options are actually related to our DataGuard system. The add standby database, which we already did in the first part, and today we will first start with this last one, that is verify DataGuard configuration. We will talk about this DataGuard administration and DataGuard performance in the next. So I will click on this verify DataGuard configuration, and it will ask for login to my primary database. I will use the sys user, and I have to use the role sysdba, and I will log into my primary database. In the next screen, it will automatically start doing the diagnostics. And it does a very nice diagnosis of the entire DataGuard system, where you can see the items that it is covering or analyzing. Like first it initializes, then it switches the current log file, performs some health checks, and also updates certain DataGuard information, verify fast start failover static service, verify protection mode, etc. All of important items related to your DataGuard system. And then it gives a detailed result in the form of a report, where you can see that most of the checks or the tests were successful, except two warnings there: checking the agent status, which is shown as warning, and it says that the default preferred credentials are not set. We can ignore the OEM default preferred credential related warnings for now. If you want, you can set it, but I will set these credentials in a future part in this series and also cover it with a little more detail. Now we see that there is no problem it has reported. Now to validate if it can catch a real problem scenario, let's stop the MRP process in the standby, and then we will run this diagnosis again to see if it is able to identify the problem scenario or report us that the MRP process is stopped. So let's go back to our standby database. I will log in as sysdba, set lines 300, pages 300, select process status, sequence hash from v $managed standby. This is the SQL query that I explained in the previous part, where it gives us all the DataGuard related processes and their status. And it gives us the information about the MRP process, which is currently applying the logs, means it is up and running. So we will stop this MRP process using the SQL command alter database recover managed standby database cancel. And this will stop the MRP process. And if we run this SQL query again, we will be able to see that the MRP process is no more present. Now we will go back to our OEM console again. Click OK to close the previous report, and then we will go to availability and then verify DataGuard configuration, this option again, to run the diagnostics. And we can see it is checking all the individual items to find out any problems in our DataGuard system. And it completed the diagnostics. And if we take a look at the report, we see that the DataGuard status has an error there where it is saying that redo apply is stopped. So it is able to catch the problem situation in our DataGuard system. And at the end also it is saying certain checks were skipped because the DataGuard has a error status. So this particular option, that is verify DataGuard configuration, is a very useful option provided by OEM, which you can use to quickly check your DataGuard for any errors or issues. Now, once you click this OK button, you will arrive at the DataGuard administrative page, where we see that in the overview section there is an error. So next we will go back to our standby server and restart our MRP process. We will use the command alter database recover manage standby database using current log file disconnect. Let's check the process status again, where we can see that the MRP process has started. Now let's go back to our OEM console again. Let's refresh this page, and this DataGuard error status should go away momentarily. Yes, it's gone. Now it is back to normal. Now the administrative page of this DataGuard system can also be accessed from this particular menu item, that is the DataGuard administration. Here in the top section, you have this overview of the DataGuard system, which displays the DataGuard status, the protection mode, and the fast start failover. We will discuss about all these things as we go. Then also it has some statistics about the primary database, the name, the host, DataGuard status, current log, properties, and some information about the standby database progress summary. That is, if there is a transport lag or if there is a apply lag, that will be displayed in this graph. Right now there is no lag, so we are not able to see any spikes in this graph. In the bottom part of this administrative page, you have these buttons: edit, remove, switchover, failover, convert. So this edit button is going to give you the options to edit the different properties of this standby database. And if you click on this edit button, you'll see all those properties which are modifiable. Under the general tab, we have the option to disable the DataGuard broker, and also we have the option to stop the redo apply, like using the apply on or enable real-time query, apply off, etc. And in the next tab, that is the standby role properties, you have the other options here which are modifiable, like the redo transport mode. You have the option to select asynchronous, synchronous, and fast synchronous options. Redo compression, which is currently disabled. If you enable it, it's going to use more CPU as expected. Then net timeout, apply delay, archive location, standby archive location. Each of these properties have the descriptions below. If you want, you can change it. As I mentioned before, all the default properties are good for us to use. Now we also have a show advanced properties option there, and you see there is a log shipping on. If you want, you can switch off the log shipping here. And DB file name convert, log file name convert, these parameters we already discussed, and you have the option to set these parameters here also. Now in the common properties tab, again we have certain things there like redo route, DataGuard connect identifier, log archive process, log archive trace, and the descriptions of each of these properties are given below. So we'll go back to the administrative page again, and here the second button, that is the remove button, gives you the option to remove one particular standby database from the DataGuard configuration. And similarly, the switch over will give you the option to switch over to this particular standby database. As right now our primary is testdg1, standby is testdg2. If you want, you can switch over to this testdg2 using our OEM console. You don't have to go to DataGuard broker like we did in the last time, and we will shortly work on this. And similarly, we have the failover and the convert button. Failover, as the name implies, you can do the failover to your standby database from this OEM console, and the convert is you can convert this standby database to a different role. For example, you have the option to convert this standby to a snapshot standby, etc. And we will cover this later on, but not in today's part. And there is an option to add a far sync. What is a far sync? Briefly, I'll tell you now. This is a different type of standby which doesn't have the capacity to take a part in the switchover or failover, but it just acts as a receiver of the archive logs from the primary or the redo log data from the primary, and it just sends them to the subsequent standby databases in the configuration. And we will cover this add far sync or the far sync standby at a later part, but not today. Then this last button, that is the add standby database, is going to give you the option to add more standby databases to the configuration. Now the performance section gives us DataGuard performance and log file details, and additional administration options are there. Verify configuration, which we did already, and remove DataGuard configuration will completely remove the DataGuard configuration, which normally we don't use. And the same DataGuard performance option you can also access using this menu item, that is the DataGuard performance. We'll go to that shortly. Before that, let's click on this log file details to see what it is going to give us. So it gives us the latest status of the log apply, and right now the primary log sequence is 12, and all those logs are already applied. As we can see this message, all logs have been received and applied, so there is no lag. Let's go back to the administrative page again. Now the next option to talk about is the performance option. Let's go back to availability menu, and under that we see this DataGuard performance. Let's click on that, and that will give us the page where we can see the current performance of your DataGuard system. In the top section, we see that the overview, where as usual it gives the primary database information, and also we get the redo generation rate. Our database is a test database, not a lot of things are happening here, so there are actually very less redo data generated, where we can see that the kilobytes per second is very less. But in a real world database or a production database system, you'll be able to see a lot of redo activity through this graph. Now here we have a very nice option to test the application that actually runs a test application to generate a load on the primary database, and thereby it creates certain redo log data, and that redo log data is then transferred to the standby database, and it evaluates the performance based on that, like how fast it is applying or receiving the redo data, if there is any lag, etc. In the bottom part of the performance page, we see the statistics about the standby database, which is testdg2, where it has two metrics here, lag times and apply rate. And in this graph, we see that there is no transport lag because there is no gray line here, but there is a red spike, which means that there was some apply lag. And it is because we momentarily disabled the MRP process for around 5 minutes. And during that period, there was no MRP process to apply the logs. So there is an apply lag happened, and that is being reflected in this graph. And in the next graph, that is the apply rate, we see there are certain spikes. And if you look at the redo generation graph above and compare the spikes with the redo apply spikes, you will see the spikes are almost similar, which means that the redo is getting applied in the standby almost immediately as it is generated in the primary. And that is what we expect in the real-time redo apply scenario. Now, we will use this switch log option to switch the log files. If you click on that, it takes just like a couple of seconds to perform a log switch, and we get the confirmation message. If you want, you can do multiple times. And then we will do a test application here. We'll click on this start button, which is going to take a few seconds to start a test application, which is internal to the OEM system. And it gives the information about starting test application. And we see that the stop option is available and also the pause option available now. If you want, we can stop or pause the application which is currently running. And as we go, the transactions per second, this is currently 0. We will see it changing in a few seconds. And I have kept the view data with a 1 minute refresh interval. So after 1 minute, we should be able to see some numbers here, which is greater than 0. If you don't want to wait, you can still click on this refresh button here. I clicked on that and I see that the transactions per second has increased to 37. And also in this graph, we can see that the redo generation rate has increased. There is a spike that has started here. And let's scroll down where we see that the apply rate has also increased in the standby. Although we don't see any apply lag, meaning no new apply lag is introduced here. This is the same spike that I already described, which was because of the MRP process stopped momentarily. Now let's refresh it again. Now we see that the transactions per second has reduced to 31. This is normal because the test application sometimes can create more transactions and sometimes it can create lesser number of transactions. And if you don't want to continue the test application to run any longer, click on this stop button and that will stop the test application so we can analyze all the statistics that it has gathered. And we see here that it is stopping the test application. We have not received the confirmation yet. So our test application has stopped and now we see that the graph has started to come down because the redo generation rate has decreased. Similarly, the apply rate has also decreased. So this is how we can do an analysis of the performance of our DataGuard system. Next, we'll go back to the administrative page and from there we will do a switchover and failover. Availability, then DataGuard administration. And now we see that the standby database is testdg2 and we'll simply click on this switchover button and you'll see how simple it is to do the switchover and failover from the OEM console. So it will ask for the name credentials to be used for the host, and our standby host is Linux 2. And if you remember, we created this NC Oracle Global, this particular name credential for both the Linux 1 and Linux 2 hosts for the Oracle user. And we will select this NC Oracle Global Host, click on the continue button, and it will also ask for the name credential for the primary server, that is the Linux 1. I'll select the same name credential here because that works for both these servers, and click on the continue button. And in this confirmation page, we just need to confirm that we really want to do a switchover. And this is a very nice option, swap monitoring settings. Always check this on because that will swap the monitoring settings from the old primary to the new primary. And this is important because we usually do not keep the same level of monitoring in the primary and standby. As a result, when the present standby becomes the new primary, you need to swap the monitoring settings. So I check this option and click on the yes button to switch over to the current standby database, that is testdg2, which is going to become our new primary. This process takes a few minutes, and first it checks the role change, restarting the new standby database, then it waits for the switchover to complete and transferring the monitoring settings. And here we can see that it gives the message, switchover completed successfully, the job and monitoring settings transfer operations may take several more minutes. So it is just finishing up the process. Let's wait for another minute or so. And if you want, you can also allow that process to run in the background. If you click on the return to DataGuard overview, the remaining process will be run in the background, whereas you can still access the main page of the DataGuard system. But I just want this process to be completed before going back to the DataGuard overview. And as soon as the last step was completed to transfer the monitoring settings, we see it has taken us back to the administrative page where we get the information that the switchover completed successfully. And now we see which one is our primary database and which one is our standby database. And in the primary database section, we see that the name of the database is now testdg2, that is our primary, and testdg1 is our standby database. Now we will do a failover. To do the failover, as you know that it is a situation where your primary database is completely gone, it is not accessible. For example, your data center is under fire, something like that. So in that case, you have to be there in the standby database itself. For example, right now, we are in the home page of the standby database, that is testdg1, which is our standby database now. And this is selected, and we just need to click on the failover, this button, and it will take us to the next page. And again, it will ask for the host name credentials for the standby host now, which is Linux 1, and we will select the same name credential, that is NC Oracle Global. Click continue. And failover is a fairly quick activity because it has to perform the things only in one database. And it says that if the primary database is still running and is accessible, please ensure that it is shut down before continuing with the failover. Now this is our test environment. Our primary database is actually not down. It is still accessible. That's why it is giving us this warning, which we can safely ignore. Now it is giving us the option of failover, that is a complete or incomplete. And the complete is all available redo data will be applied on the standby database, thereby minimizing data loss. Oracle recommends this type of failover. And the immediate is going to take place immediately to save time so that your database is immediately available for the users or the application. But it may result in losing some data. So we always go for the complete option, where we make sure that there is no data loss. So I selected the first option, and again this swap monitoring settings, we will check this option here and click on the yes button. The failover activity, as I explained, it needs to be taken place only on the standby server, and that's the reason it is a quick activity compared to the switchover activity. And again, it is giving us the option to return to the DataGuard overview. If you want, you can allow the remaining processes to be run in background and go back to the overview page, but I want it to be completed. And we see that the failover completed successfully, and we came back to the administrative page. And now our primary database is again testdg1, and the standby database has a fairly different information displayed. In the DataGuard status, we see that the database must be reinstated. It's because once there is a failover, it means your primary database was completely destroyed or it was gone. If after a failover, your old primary database becomes accessible, then the reinstate process will try to revive it or bring it back to life as a standby database using the flashback logs and all the archive logs that were generated after the disaster took place. That's the reason it is very important to enable flashback database with a reasonable flashback retention period in the database. If the reinstate process fails, then you will have no option other than recreating the standby database. And that's the reason this particular status is shown as database must be reinstated. Now, if you click on this, the reinstate process will start automatically, and that will bring your entire DataGuard system back to normal status. So I will click on this database must be reinstated option here, and in this page we see that there's a reinstate button available. We will ignore other options like enable real-time query, etc. We'll just click on this reinstate button, and in the next page, that is the confirmation page, we will just click on this yes button to confirm the reinstate of the database. And again, it is asking for the name credential. We'll use the same name credential for the host, NC Oracle Global. Click continue, and the reinstate process will start, which will hardly take a few minutes. And we see that as soon as the reinstate process has completed, it took us back to the overview page or the administrative page of the DataGuard system, and we get the message here, database testdg2 has been successfully reinstated. Let's refresh this page, and we see that the DataGuard system is back to its normal state as before, where the primary database is testdg1 and the standby is testdg2. And also, we see under this standby database section, certain information has changed. For example, the last received log file sequence has reset now to 1, because once you do a reinstate of the database after failover, the log sequence is also reset to 1. So that's the reason we can see that the last received log is 1 and last applied log is also 1 now. And the estimated failover time is again less than 1 second. Now we have come to this episode's last item, which is about OEM monitoring and setting up alerts for the DataGuard status. Please note that setting up notifications, alerts, and monitoring in OEM is a separate topic. I have a separate video in my Mastering OEM series dedicated for this. If you want to get your hands on setting up the full OEM monitoring, please watch that video using the link in the description of this video below. I assume that you already have your OEM monitoring framework in place with target groups, incident rules, etc. Most of the time, the default metrics collected for the database instances work great for the monitoring of your DataGuard system. But sometimes you need a little extra. For example, here I am demonstrating how you can set up an alert for log gap detection using a metric extension. Say you want to send a warning alert when the log apply gap between the primary and the standby reaches 5 and a critical alert when it is 10. Let's learn how we can do that. First, we need a SQL query which will detect that log gap when it is run against the primary database. So I connected to my primary database using SQL Developer, and this is the query that we are going to use. And if you remember, in the second part in this series, I shared a SQL query to detect the log gap. This is the query, and we will first simply run it against the primary database to see what it returns. So the result says the primary database, the primary host, log archived, destination ID, log applied in the destination ID, applied time, and the log gap. It means right now there is no log gap. So we will artificially create some log gap by stopping the MRP process and doing some log switches in the primary so that the gap increases, and that gap can be detected by this query. So we will go to our primary database and connect to the primary database as sysdba and do a archive log list to see what is the current log sequence, that is 2, which is in progress. Before we do a few log switches in the primary, we will go back to our standby database and I connected as sys, and then we will stop the MRP process. Just to make sure that there is no MRP process running. Yes, there is no MRP. Now the log apply service is stopped. Now let's go back to the primary database and we will do a few log switches. Alter system switch log file 1, 2, 3, 4, 5. So we did 5 log switches in the primary. So the log sequence should have increased to 7 now. I'll go back to our SQL developer window and we will run this SQL query again. And we see that the log gap is currently 5 because we did 5 log switches. So with a little modification into this query, we should be able to use it in our metric extension. So let's make a copy of this query, paste it below, and we don't need all this information like primary database, primary host. All we need is this log gap, which will be used by the metric extension to determine whether it's a warning or critical situation. So in this query, we will remove all these fields except the log gap field. So select log archived minus log applied, which is actually the log gap, and rest of the things I'm keeping the same. And also we don't need this order by clause. Let's execute it for the one last time and see. And it gives us just the piece of information that is needed for our metric extension. Then I will go back to our OEM console. So we arrived at the administrative page of the DataGuard system. And as expected, we can see there is an error because we just stopped the MRP process. Now, to create the metric extension to monitor the log gap, first we'll go to this enterprise menu. Under that, go to monitoring, and under that, go to metric extensions. And in the metric extensions page, we will click on this create button first and select the metric extensions. In the metric extension creation process, we will go to the general properties, and the target type here will be database instance, because this metric extension will be applicable on only database instances. And let's put a name like detect log gap. You can put any name here which is meaningful to you. I'm using this name here, and we'll use the same name as display name also, detect log gap. And the adapter that is giving us a couple of options, OS command, multiple columns, SQL, and it is going to be SQL because we are going to use a SQL statement to detect the log gap. And the description will be, say, ME to detect standby log gap. Data collection, you should keep it enabled for future use. Data upload, yes. Use of metric data, alerting and historical trending, let's keep it on, because if you want to see any trend in log gaps, you should be able to see the history. That's why we should keep this option on. Upload interval, one collection frequency by minutes, and the repeat every 15 minutes option is there. It means this metric extension will check the log gap every 15 minutes. Just for information, you don't have to select anything in this advanced section. Then click on the next button. Now here we have to put the SQL query that we tested in our SQL developer. So let's copy it from there, paste it, And you can also use a SQL query file instead if you don't want to use the SQL query. But that file has to be present in all of the servers where you want to deploy this metric extension. And under the advanced properties, we don't have to put anything. Connection properties, let it take the default ones. Upload custom files, you don't have to do anything here. And we will click on the next button. Now the columns. Columns are nothing but the field which is going to accept the value returned by the query. If you remember, our query returns only one numerical value, which is nothing but the log gap. So we'll add one column to receive that value in the OEM side. So click on the add new metric column. And here we will simply put a meaningful name like say log underscore gap. And display name of this variable will be also log gap. It is a numerical value. There is no unit required. And the category, you should select something meaningful that actually represents the scenario for the log gap. So we will take it as a availability. And the transient option should be false, as it also mentioned why it should be false. Then alert thresholds. As we discussed before, we want the warning situation to be greater than or equals to 5, and the critical situation should be greater than or equals to 10. Manually clearable alerts will be false because we don't want to clear it manually. As soon as the underlying situation is resolved, for example, if there's a log gap because of a network issue, and that network issue is resolved, and as a result the log has been transferred, or the MRP process is able to catch up all the pending logs, then this metric extension will evaluate the situation and it will automatically clear the incident. So that's the reason we don't have to set this manually clearable alert. It will be false. And number of occurrences before alert, it is going to be 1. Now this alert message, what alert message will be most meaningful for you? So this percentage column name is nothing but the display name that we have set here, that is log gap, and the value will be the one that will be returned by the SQL query. So whenever one alert will come from this metric extension, your message in that alert will look like the value of log gap is a number like 5, 10, something like that. So we are okay with that, so we'll keep it that way. And under compute expression, we don't have to set anything. We will simply click OK. So we have defined the numerical column to receive the value returned by the SQL query successfully. Now we can click Next. And in the credentials section, we will use the use default monitoring credentials. And then we'll click on Next button. And here we need to test our metric extension, because before we deploy it, we need to make sure that it is working as expected. And it will be tested against certain targets that we can select here. So under the test targets, we will click on this Add button, and it will give us all the database targets which are available in this OEM system. And we will use our primary database target, that is the test DG1. Select it, then select the line again and click on this Run Test button. It should return a value 5. And below, under test results, we can see that the log gap, this is the message we are able to see, which is 5. So it means the metric extension is working as expected, and there is no error message because this metric extension did not encounter any error. You can leave it like this, the test targets. It doesn't make any difference. So click on the Next button, and it is giving a summary page. and we will click on the finish button. And in the list of metric extension, now our new metric extension is available, where we see this one, detect log gap. Let's increase the height of this window. Let's close the confirmation message and select the line with the metric extension that we just created. Now this metric extension is actually created, but it is not yet deployed to any of our database targets. To make use of this particular metric extension, we must deploy it on certain targets on which we want to run this. To do that, we'll select that metric extension, go to Actions menu, and the first step to do that is to save as deployable draft. Let's click it. And the metric extension has been successfully saved as a deployable draft, and the version is 1. The version is given here so that we can do modifications in this metric extension if required in the future and create subsequent versions like version 2, version 3, etc. Let's close the confirmation message. Let's select the line again, go to Actions menu, scroll down, and then we will publish this metric extension. So publish is nothing but this metric extension becomes global so that other administrators or users in this OEM system, whoever has access to this metric extension, will be able to use it on their respective targets if required. So we will publish it, and we got the confirmation that it has been successfully published. Let's close it. And now we are ready to deploy this metric extension. And if you go towards the right, you see that deployed targets is currently 0. So it is not deployed on any database targets. So we will select this line, click on the Actions menu again, scroll down, and select this Deploy to Targets option. Now in the next screen, we have the option to select the database targets on which we want to deploy this. So we will deploy this on our primary database because this is going to run against the primary database, not against the standby database. Please remember that when this primary database will change the role to a standby database and the old standby database becomes the new primary, in that case, these monitoring settings will automatically take place. If you have multiple databases in your OEM system as target databases where you want to deploy this metric extension, then you can select all those database targets here using Control-click. Because we have only one database, that is the testdg1, which is our primary database, and it has the DataGuard configuration with one standby. So we are going to select only this one and then click on the select button. And the selected database is displayed in this list. And now all we need to do is to click on this submit button. And it says that the deploy operation has been submitted, and currently the status is scheduled. If we refresh this page, if it is completed, then this line should go away. Yes, no data found means the deploy operation has been completed. Now let's go back to our metric extensions page again, where if we see the metric extension detect log gap, there we see that the deployed target is now 1. Earlier it was 0. Now it means that our metric extension is now fully operational on this database target. Now, as we deployed it in our database target named testdg1, where already there is a log gap of 5, we should be able to see one warning alert on that database target. So let's go back to all our targets. Let's right click on our target database testdg1, go to Oracle database menu, and under that monitoring, and under that incident manager. And at the top of the incident manager's page, we see that there is an incident. If we increase the width we are able to see the full message here. The value of the log gap is 5, exactly what we expected from the metric extension. Now select that line and we will see what additional actions it has taken. Let's increase the height of the bottom window and click on the events tab, and under the events we'll click on this message, the value of log gap is 5, and it will take us to the next page where we'll be able to see the series of actions it has performed as per the incident rules. And if we go to notifications, we should be able to see all the actions it has performed. So in the first place, it says that the following notification will be sent to 1 email and 1 recipient, which is already done at 5:23:26 seconds. And the next action it performed was sending an email. This is my personal email ID. And under the rule which was created by sysman with the rule name myRuleSet and rule myRule1. Again, if you want to know more about how to set up your notifications, alerts, etc. in OEM for your database environment, please watch my dedicated video on that, which is there in the Mastering OEM series. But for your convenience, I have also mentioned the link to that particular video. Now, just for the completion, I will go back to my personal emails inbox to see what message I just received. At the top of this inbox in my personal email, I can see that there is a warning alert from the database test DG1, and the value of log gap is 5. And if I click on that, we can see the details in the email body. Now I just restarted my MRP process and also check the status of the DataGuard related process where MRP has applied all the logs. So the gap from 2 to 7, which was 5, has been removed and it is now current with the primary. So we should be receiving one clear alert for the warning alert that we received before. Let's go back to my inbox again, and on the top of the inbox I can see that there are 2 messages. Both are clear. One is for the metric extension and it says the alert for the log gap is cleared, and the other one is also related, that is the DataGuard status of test DG2 manage.home is now normal. So let's click on the first one where we see all the details about the clear message. And similarly, if we go to the second one, there also we see that the metric value is now normal or a 00. It is successful completion. So it means our testing has been successfully done. And this is how we'll be able to set up an alert and monitoring on our DataGuard system on detecting log gap and alerting. So viewers, this is enough for today. In the next part, we are going to cover log gap detection as well as resolutions under different scenarios. So viewers, please provide your feedback in the comment section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.